Hello everyone, welcome to Math with Allison. Today we're starting a new series. We're working into derivatives. If you haven't already, you can check out my series on limits. It's super awesome. Click that little eye in the corner and it'll get you there. Otherwise, we are talking about derivatives. What are they? So we're going to go into a general description of them and just start playing around a little bit. But let's go ahead and dive into it. So I have a beautiful drawing here and we have the function x squared. And on it, we have what is going to be new, the tangent line at the point 2, 4. So the tangent line is a line that just skims the function at a particular point. So I chose the tangent line of the point 2, 4. Of course, it would look a bit differently if I chose the tangent line of the opposite point right here, because again, it'd be the line that just barely skims it like that. So tangent lines are different according to what point you choose. But that's what it looks like. And actually, we can find the value of the slope of the tangent line. So I have that definition written out right here. I have m, also stands for slope, is equal to the limit as x approaches a of f of x minus f of a over x minus a. This is very similar to the change in y over the change in x, right? If I say, oh, I'm just going to take a random x value right here, and this is my a value, which was 2. So if I were to write out the slope, right, I would take my f of x and I would subtract my f of a, but remember that value is 4 because that's my corresponding y value. This one's f of x just because we chose a random x value. I'm saying it's not defined, all over x minus 2. So it's just like slope, and we're going to go ahead and calculate that from our example. So I'm going to go ahead and write it out. So in this case, our a was going to be 2. We take the limit as x approaches 2 of f of x minus f of 2 all over x minus 2. So we need to go ahead and plug in some values. That limit doesn't change at all, right? But I know what f of x is equal to. I know that's equal to x squared. And I also know when I plug in 2, I get 2 squared all over x minus 2. I'm going to go ahead and simplify that out. If I look at the numerator, I can see that I have a difference of q's. So I'm just going to go ahead and factor that out. And now I can see our issue, which was x minus 2 in the denominator, that divides out, right? And all I'm left with is the limit as x approaches 2 of just x plus 2. Now I can go ahead and use direct substitution. I can just plug in that value 2. So I get this is equal to 2 plus 2, which is equal to 4. And this is going to be our slope. Now how we find the equation of the tangent line is just algebra. I have that written out right here. Y minus y1 equals m times x minus x1. And remember, our point was at 2, 4. So this tells us our x1, and this also tells us our y1. If I plug those in, I get y minus 4 equals 4 times x minus 2. I'm just going to go ahead and solve for y. So I get y minus 4 equals 4x minus 8. If I add 4 to both sides, I get y equals 4x minus 4. So the tangent line of x squared at 2, 4 is y equals 4x minus 4. And if I go back up to my drawing, that is going to be the equation of the blue line, y equals 4x minus 4. So that is how we can actually find the equation. We use limits. So there is another way that we can do this. This is where we take the limit as h approaches 0 of f of a plus h minus f of a all over h. So this is a different type of limit. We're going to go ahead and see what that looks like here in this drawing. It is again very similar to change in y over change in x with the addition of a limit. So right here I have my a value and the corresponding f of a. And then I add a little distance of h, and I get a new x value of a plus h. And I have the corresponding y value, f of a plus h. So if I were to do change in y over change in x, I have f of a plus h minus f of a, all divided by a plus h minus a. So notice here, actually, the a's cancel out. And so here I'm left with f of a plus h minus f of a, all divided by h. And if we remember, that's exactly what was inside our limit. So why are we taking the limit as h approaches 0? And it's because that slope changes as f of a plus h gets closer and closer to f of a. So what I mean by that is first we start off with a slope kind of like this. I just drew it in right here. But I'm minimizing h. This distance right here is going to 0. So maybe as I get really, really close, now I have a point right here. I made h much smaller. And notice here my slope of this new line is going to be a little less slanted. So that would happen the closer and closer I get, and we end up, as h closes in and goes to 0, at the actual slope of the tangent line. So let's go ahead and calculate this out. First, we have the same function, x squared, and we have the same point, and we're going to use this new method. So I have the limits written out already, and what I want to do is plug in my corresponding a. So I get f of 2 plus h minus f of 2 all over h. That h doesn't change. And so now I need to put in my input. I highlighted the different inputs that we have here, and f of 2 plus h is going to be 2 plus h squared. Because f of x equals x squared, I'm just squaring my input. Now f of 2 is equal to 2 squared, all divided by h. I'm going to go ahead and math this out real quick. So here I can see some terms that cancel out. I get 4 and negative 4. So those go away, and I get 4h plus h squared all over h. We can see that an h is going to divide out, but I'm going to show us that. I pull out an h from the numerator, and I'm left with 4 plus h, all divided by h. So now I can see these divide out. I'm just left with the limit as h approaches 0 of 4 plus h. So I can go ahead and use direct substitution. I get 4 plus 0, which is equal to 4. And this was the same slope that we got last time. It was just a new method of getting there. So I have another example for us. We have f of x equals square root of x plus 3 at the point 1, 2. So we want to go ahead and find the entire tangent line. First, when we need to find the tangent line, we need to find the slope. So I have that formula written out for us here, and we're going to go ahead and plug in what we know. So in our case, h is approaching a value of 0. Sorry, that's not a, that's supposed to be 0. And my a value is going to be the corresponding x value. So my a value is going to be 1. So I get f of 1 plus h minus f of 1 all over h. When I plug this into my function, I get the square root of, instead x plus 3, 1 plus h plus 3, minus f of 1. I plug in 1, I get 1 plus 3. That h in the denominator stays the same. I'm going to go ahead and simplify this out a little bit. Okay, so what we need to do here is we want to get rid of that h in the denominator because we can't plug that in, right? So what I want to do is multiply both the numerator and the denominator by the conjugate. So I'm going to multiply it by the conjugate of the numerator. Here I get the square root of 4 plus h plus 2, and I'm going to multiply the denominator by the same thing. Let me go ahead and work that out. So the point of doing this is so the 4's cancel here, and notice I'm left with just an h in the numerator. And that means that h can go ahead and divide out. So if I rewrite this, I get the limit as h approaches 0 of 1 in the numerator and that whole denominator. And now I can go ahead and plug in what h is equal to. So if I use direct substitution here, I get 1 over the square root of 4 plus 2, which is equal to 1/4. So I'm going to go ahead and fill that in right here. I have a slope which is equal to 1/4. And now I can use all of this to find the tangent line. So I get y minus y1, which is equal to 2, equals 1/4 x minus 1. If I multiply this out, I get 1/4 x minus 1/4. I'm going to go ahead and add 2 to both sides. But remember that 2 can be rewritten as 8 over 4. This way we can go ahead and combine those. So here I get y is equal to 1/4 x, and now I get plus 7/4. And that is the equation of our tangent line. So we have one more example here. Again, this should be a 0. And now we have 1 over 3 minus 2x at the point -1 and 1/5. So first I want to go ahead and calculate the slope. So let's go ahead and plug in what we know. I'm going to take the limit as h approaches 0, And now my a is going to be negative 1. So I have f of negative 1 plus h minus f of negative 1 all over 3 minus all over h. I'm going to go ahead and plug in what we know. Okay, I plugged in my inputs, and now I want to go ahead and simplify that out a little bit. So my limit doesn't change, but I'm going to go ahead and simplify the numerator. So notice now we have a lot of fraction action going on. I want to go ahead and combine the fractions in the numerator, and in order to do that, I need to create a common denominator. So I'm going to multiply my fraction on the right by 5 minus 2h on both the numerator and the denominator. And then similarly, on this other fraction here on the left, I'm going to multiply both of them by 5 over 5. So I'm going to go ahead and write that out. So now that I have a common denominator, I can go ahead and combine those two fractions. So here I have the limit as h approaches 0. And now what I'm going to do is I'm going to pull that h out, and I'm going to rewrite that as 1 over h and then times the numerator. That way we don't have so many fractions going on. And here I get 5 minus 5 plus 2h. Don't forget we need to distribute that minus to both terms. All over 5 times 5 minus 2h. So notice here we're going to have some things that cancel out. First, the 5 minus 5s are going to go away, and now we just have a 2h in the numerator. Notice here that these h's actually divide out. So what we're left with is the limit as h approaches 0 of 2 in the numerator, and then we have that 5 over 5 minus 2h. Now we can go ahead and use direct substitution in this. So here I'm going to go get 2 over, which this is equal to 2 over 5 times 5, which is equal to 2/25. And so now I have what our slope is equal to. Our slope is equal to 2 over 25. And now I can go ahead and use all of this information to find the tangent line. So let's go through this. I get y minus 1/5 equals 2 over 25, x plus 1, because I subtract a negative 1. I'm going to multiply that through, so I get 2/25 x plus 2 over 25, and I'm going to go ahead and add that 1/5 to both sides. So remember, our 1/5 can be rewritten as 5 over 25, just by multiplying the numerator and the denominator by 5s. That way I get a common denominator, and when I go ahead and add all of this up, I get y is equal to 2 over 25x plus, and that becomes a 7 over 25. And that's the equation of my tangent line. So that is all I have for us today. If you enjoyed this video, please leave a thumbs up and comment other topics or videos you'd like to see done. Thanks for watching.